All right, so last lesson I've asked you guys to complete a graphic organizer, and I just want to quickly go through the graphic organizer with you guys. So you started off with ceramics, and the structure of ceramics is kind of like a crystalline structure. You can call it a matrix arrangement of atoms. And if you look at the chemical bonds, how atoms are being bonded with each other in ceramics, they usually they usually consist of both ionic bonds and covalent bonds. So remember, covalent bonds are they usually exist between nonmetals, and ionic bonds exist between metals and nonmetals on the periodic table. So since they are composed of both metals and nonmetals, so they have both type of bonds. Now, the property of this material, they're usually quite brittle because you have electrons being locked inside the bonds. So when you want to try and break that bond, you actually take a bit of force to do that. But once you break it, the two atoms falls apart completely, causing the material itself to split among themselves. So that's why it's being brittle. It's also a very good insulator because usually when it comes to conducting heat and conducting electricity, it takes the electrons to do it. And because electrons are kind of being locked in the bonds and it can't really jump around much, it's very good at locking in heat and locking in electricity and not allowing it to go anywhere. And that is the reason why it also has a very high melting point, because it's so strongly locked together. It actually takes a lot of heat energy to break the bonds and cause it to melt. And the function of ceramics, I think you guys are pretty much all set for that one. I saw correct answers in all of your documents. And then composites. So composites are made up of two different types of material being combined. And the structure of it really depends on what type of materials are being combined. Sometimes they can be in layers and compressed. Sometimes they are just two being just stirred and mixed in. So it really depends. And the property also varies a lot depending on what type of materials are involved. So usually we have composites when we have a very specific function that we are trying to achieve, and we would choose materials, two or more materials that kind of fulfill those properties that can execute that function, and we'll mix it together and making it, yeah, so basically putting materials together so that you can achieve that function. So the function really varies a lot. Polymers, so we have this idea called, we have monomers, and when monomers are chemically bonded together to form a chain of repeating units of monomer, then we call it a polymer. So you can think of it this way. The monomer can be one bead or one pearl that you have in a bracelet or you have in a necklace. And when you chain them up together of repeating units of pearls or repeating units of beads, then you can turn it into a polymer, a long chain. And some of the property is that it's quite flammable because of the way of how it's being bonded. It can react quite well with hydrogen and produce combustions. The hydrogen bonds will tend to repel water. Malleable or flexible. So when you have a chain of polymer, you can actually bend them quite easily. And the melting point really varies a bit. It really depends on the intermolecular forces. So when you have strands of polymers, they're also lying next to each other. Now, between those strands, how are they being intermolecularly bonded? The attraction between the strands can differ. So if you have a strong attraction between the strands, you will have a higher melting point because it takes more heat to break the higher attraction between them. Functions, well, since there's such a wide variety of polymers, you can use it for bags, they're fibrous. Yeah, it just really depends. Metals, metals is quite specific when it comes to structure. Metal atoms have free-flowing electrons. So they have one dangling or two dangling electrons around the nucleus. So if you look on the left-hand side of the periodic table, you can see that. And those electrons tend to just flow around, jumping from one metal atom to the next metal atom. Now, because you have this movement of electrons, the property of metal, when you look at it, it's able to conduct electricity. It conducts heat also very well because electrons carries energy. It's malleable because the atoms are being attracted to each other with the positive and negative ions. So you can actually kind of put force on it and it will slide against each other, but they will not fall apart. And that's what makes something malleable. It's also ductile, so that means you can kind of roll it past each other, stretch it. It's quite shiny because when you shine light on it, the electrons that are jumping around kind of reflect the light. It's also quite reactive because they always want to lose one or two of their electrons, so it can react just sitting there in the air, react with oxygen and produce rust. Function, because of the conductivity of heat and of electricity, we use it to make wires, we use it to make our pots and pans. So yeah, there we go. I want you to just use this data. You can go back and pause videos in between to complete and make your graphic organizer more perfect.